Welcome to What is Chromatography? So chromatography works on the same principle as solvent extraction does, but one phase remains stationary as the other phase flows past it. This is the mobile phase. So a simple chromatography column is shown here at various times. So our column is packed with solid particles we have going all the way up to the top, and those solid particles are phase 1, and then it's filled with solvent 2 that flows around those solid particles. And when we then place our solution containing solutes A and B on top of the column here, and then we open a valve at the bottom allowing the solvent to drain out, and we slowly replace more solvent at the top, then that band containing our solutes A and B slowly moves down the column. And again, as the solvent moves down the column, we keep pouring in fresh solvent at the top of the column to replace the volume that's flowing out at the bottom of the column. Now, suppose that solute A is more strongly adsorbed onto our particles, this is phase 1, than solute B is. This means that our solute A will spend a larger fraction of its time on the particles, adsorbed onto those particles, and thus less of its time in solution. And therefore, if A is spending less of its time in solution and more of its time on the particles, then it will not travel down the column as fast as B does. In other words, B travels faster down the column than A does because B is spending more of its time in the solvent than it is adsorbed onto those solid particles. Whereas A is spending more time adsorbed on the particles relative to B and less time in the solvent compared to B. And we can see that occurring here, that initially A and B are overlapping, and as they move down the column, A moves slower than B does, and at some point B comes out and A is still way up here in the column, and then at some point later in time, A moves from the column. So the mobile phase is the solvent that's moving through the column, and the solvent is either going to be a liquid or a gas. The stationary phase is that phase that stays in place inside the column, and is usually a viscous liquid chemically bonded to the inside of a capillary column or onto the surface of solid particles packed into the column. And in our simple column shown earlier, that stationary phase was the solid particles themselves. So fluid that enters the column here is called the eluent, while fluid leaving the column at the bottom is called the eluate. And elution is the process of passing liquid or gas through the column. So columns can be either packed or open tubular. Packed columns contain solid particles, which then provide a surface for our stationary phase, or are themselves the stationary phase. The open tubular columns are narrow, hollow capillaries with the inner wall coated with our stationary phase. And we have different types of chromatography. We can divide our chromatography into categories based upon the interaction of our solute with the stationary phase. So in adsorption chromatography, the stationary phase is a solid like this, and a mobile phase is liquid or gas. The solute is then adsorbed on, so we've got our solute particles here in gray. They're adsorbed onto this sort of bluish particle here. That's our stationary phase. So solute is adsorbed onto the surface of our stationary phase, and the more strongly the solute adsorbs, the slower it's going to move down the column, because the larger fraction of time it's going to spend adsorbed, and thus the lower fraction of time it's going to spend in the mobile phase, moving past the stationary phase. In partition chromatography, the stationary phase is a liquid that's bonded to a solid surface, which is often the inside of the silica column for gas chromatography. So we've got here our stationary phase, and then down the middle is the mobile phase, and that's going to be a gas. And the solute equilibrates between the mobile phase in the middle and the stationary phase coating the walls. In ion exchange chromatography, anions such as the SO3- or cations such as this tertiary amine are covalently bonded to our stationary phase, which is generally a resin. And solute ions of opposite charge are then attracted to the stationary phase and are retarded. The mobile phase must be a liquid in order to carry the ions. We can't have the ions moving through a gas. With molecular exclusion chromatography, we're separating our molecules by size. So ideally, there's no attraction between the solute and the stationary phase, so it's not adsorption chromatography. Instead, that mobile phase, which is either a liquid or a gas, is passing through some sort of porous gel, and small molecules enter the pores and are retained for some time, but large molecules cannot enter the pores and thus move down the column faster. We also have affinity chromatography, in which a molecule that is immobilized by being covalently bonded to the stationary phase is used to selectively bind our solute molecules of interest. For example, the immobilized molecule may be an antibody that selectively binds a protein. And then when a mixture of many proteins is passed through the column, then only the protein that binds to that antibody will be retained on the column. And once all the other proteins have eluted off the column, then the pH or ionic strength can be changed so that we can dislodge that analyte protein from the antibody. And now we've effectively separated that protein from all the other proteins around, and now we can perform some analysis on that. So that was, what is chromatography?